Okay, let's talk about the formula that we get for Young's two-slit experiment and actually see where that formula comes from. So we've got light arising in phase at two slits, and we're calling the separation of the slits A, okay? And we know that at this screen, which is a distance d away, we'll get a pattern of fringes. And we know that bang in the middle, at the centre point, because the light for the from the two slits has got exactly the same distance to travel, they'll arrive in phase, so we'll have a bright fringe in the centre. And the next bright fringe on either side will appear when the path difference in the light from the two slits, so this distance looks a little bit shorter than that one, when that distance and that distance differ by exactly one wavelength, we'll get the next point of maximum intensity. And we're going to call the distance between these fringes from the first one to the second, let's call this distance x. Okay? So, how the separation of these fringes is actually going to depend, obviously, on that path difference that we need, which we called lambda. Okay? So there's a relationship between lambda and these numbers a, x, and d, and that's the relationship that we're going to derive. You won't need to do this proof, it's just a bit of mathematics really, but I'd like you to know where the formula comes. So I'm going to simplify my diagram a little bit. I'm just going to have the positions of two fringes here, or 2 points. I'm going to have this point here, which is the centre point, and let's have up here, I'll make it a little bit bigger for clarity. Okay, so this distance x is my separation of the two fringes. And I'm going to be looking at, in fact, two right-angled triangles. So here comes my first one. Well, the two distances I'm interested in. Let's draw in the distance to this first fringe, first-order fringe, from the further slit. Okay, so we'll call this distance d1. Okay, and then I'll work out the distance d2 from the nearest slit. Okay, so let's draw this right-angled triangle. Okay. So, we now have the hypotenuse is d1, and of course the distance here is the distance to the screen, so this is d. And this distance, well, I've got distance x between the fringe and the centre point, but this centre point was halfway between the two positions translated to the screen of the two slits. So the centre point would actually line up with this middle point here. So I've got a little distance here of a over 2, where a is the separation of the slits. And now I've got the information I need, I think. I can just apply Pythagoras to that triangle. I'll get rid of this to give myself a bit of space. Okay. So, well, in fact, you might want to write down before the next video what you think I'll get when I apply Pythagoras with that length, and this length, where I have to add these two together. You don't need to simplify, just apply Pythagoras.